Suppose I asked you to evaluate log base 2 of 4. Another way of asking this is 2 to what power would result in 4? And the answer is 2 to the second power. So log base 2 of 4 is equal to 2. So that's not too bad. What about this next one? What about log base 2 of 8? Well, based on the same logic, 2 to the third power is equal to 8. So this would be equal to 3. 2 to the third power is equal to 8, right? What about if I asked you to do log base 2 of 6? 2 to what power would give us 6? And the answer is, I don't know. And I actually don't. I know approximately it's going to be between 2 and 3, but I don't know that much more precisely what it is. And the issue is the fact that 6 is not the result of taking 2 to any integer power. So then we're stuck with being a little stuck here. And this is where the change of base formula comes in. And the change of base formula effectively says that when you have log of some base to some argument, log base 2 of 6 in this case, you can actually rewrite this as, let me get this out of the way, you can actually rewrite this as log of 6 divided by log of 2. And this will allow you to evaluate this a little bit more efficiently in your calculator. Some calculators do allow you to directly put in log base 2 of 6. Most graphing calculators do. But if you're not working with a graphing calculator, you really have no choice but to be able to evaluate or punch this into your calculator in this form. So the change of base formula says that provided that you are using you're taking the log of the same base in the numerator and denominator, the same base in the numerator and denominator. Log base b of x can be written as log base 10 of x over log base 10 of b, or you could say the natural log of x over the natural log of b, or you could even say something like this would be equal to log base 17 of x over log base 17 of b. Honestly, what the base is doesn't matter as long as they are the same. Now, why does this work? Why does the change of base formula work? Well, here's a really quick and easy proof for the change of base formula. And I want to start with writing log base b of x is equal to y. Well, the first thing I'm going to do now is to actually write this in exponential form. So we're going to say b to the y power is equal to x. B to the y power is equal to x. Again, all I did was write this in exponential form. Now, if you recall, one of the properties that we learned so far is that if you have a log base b of, let's just say a, let's not use a, let's actually use x. And then you say that this logarithm is equal to this logarithm. What we saw then is that if these two logarithms are the same and they both have the same base, that means these arguments must be equal to each other. They must be equal to each other. So if that is the case, we can actually then apply the log of both sides. That is to say, I can write log of b to the y must be equal to, let me write this here, log of x. In other words, we can just take the log of both sides and both sides will still be equal to each other. Well, why would I want to do this? Well, now that we've discussed the previous properties, including the power property, I can move that y over here and write this as y log of b is equal to log of x. And this is where you should be getting pretty excited because you could probably see where this is going. If I isolate y by dividing both sides by log b, I get log of x over the log of b. And what do you know? That all of this is what is equal to y. So we can say that log base b of x then is indeed log x of log b. So again, in practice, the way we would use this is we would just be able to write some of these logarithms now as the log of our argument over the log of 6. Number 2 here, I would write this as log of 13. Oops, sorry about that. Okay, log of 13 over the log of 2. And if I wanted to do this with natural logs, I could say something like natural log of 24 over the natural log of 6. Well, hopefully that's helped. And now that we have the change of base formula, that'll allow us to also rewrite certain logarithms, such as the one that I did in the previous video.